Okay, now we're going to look a little bit into factoring. And this isn't everything you need to know for factoring, but these are these things will come up a lot. There's a little bit more you need to know, but this will do for now. So first one, we just have this linear expression, 3x plus 9. We want to factor this. We're just looking for the greatest common factor. And here I'm looking at 3 and I'm looking at 9. And I know that 9 is divisible by 3. So that means I can sort of pull out a 3 from both of these terms. And if I wanted to write it really kind of clearly, which I don't expect you all to do this, I could rewrite it as 3x, and I'm actually going to put parentheses around this stuff. 3x plus 3 times 3. Both of these terms, this 3x and this 3, they both share a 3 in them. So that means I can pull out that 3, and I can rewrite it as 3 times x plus, because there's a plus right there, plus 3. And that's how we do the first one. And I wrote it out that way for kind of a reason, as we'll get into the next one. But for this next one, we have x squared plus 2x plus 1. We have this quadratic expression. If we're just looking at this side, this expression that we're trying to factor. And so first off, I need to look at my leading coefficient and my end coefficient. And our leading coefficient here is 1. So we have a 1 and 1. And I'll write it the way I write it sort of for algebra 1. We have 1 times 1, which is 1. That's not how I draw my t-charts. We have 1 times 1. We're looking for factors of 1 that add up to 2. This one's very simple because the only factors of 1 are 1 and 1. 1 times 1 equals 1. Let me restate that. 1 times 1 equals 1. And 1 plus 1 equals 2, which is our B, our middle coefficient. And with that, I can rewrite this, and I'll do it by grouping, because I've heard that grouping is popular. X squared plus x. Again, we have an invisible 1 here because it's just 1x. Plus x plus 1. This is a sort of bad example to do grouping on, but now we're going to look at this expression here, and we're going to group our first 2 terms and our last 2 terms, and we're going to see, do either of these have a greatest common factor? And we're going to do the same principle that we did here on this first one. X squared and x, their greatest common factor is just x, so that means I can pull an x out, and we have x times x plus 1, because x times x is x squared, x times 1 is x, and then just plus x plus 1. I guess the grouping will be nice for this part of it. And now I'm going to look at these 2 terms. So we have x times x plus 1, that's all one term, and we have this x plus 1. These are our 2 terms. And what do they have in common? What is their greatest common factor? Well, their greatest common factor is these x plus 1s. So now I'm just going to come down here because I'm running out of space. And so that means we can pull out an x plus 1, and I'll leave that in parentheses. And what did we leave behind? Well, we left behind an x And it seems like we left nothing here behind, but really we did leave something behind because we pulled it out, we divided by that. Pulling that out is the same thing as dividing. And x plus 1 divided by x plus 1 leaves us with 1. So we factored that, and really I'd be okay if you stopped there, but just to show you what a fully simplified one would be, we would have x plus 1 squared. As of right now, I don't need you to do this squared part, but just to show it. And our last example that I'm going to do is this 2x squared plus 11x plus 12. We're going to do the same procedure that we did with this one right here. We just have to be careful because now our leading coefficient is a 2, and our last our constant is 12. So if I draw my little table, I'm going to do 2. Oh, let me wait for it to... Okay, sorry, I had to wait for it to catch up a little bit. We have 2x squared plus 11x plus 12. We need to multiply our underlined things, in this case, our leading coefficient and our constant. 2 times 12 is 24. And here we actually have a lot of factors we could do. If you're quick with it, you won't need to list them all out. But we have 1 and 24, we have 2 and 12, we have 3 and 8, and our next one would be 8 and 3, which is the same thing. This 8 does not look very good, so let me rewrite that. 3 and 8. And we're looking for which of these terms will add up to our b. So we want positive 11. 1 plus 24 equals 25. That's not 11. 2 plus 12 equals 14. That's not 11. 3 plus 8 equals 11. This is what we want. This is how we're going to split our middle term. And again, doing it by grouping, we're going to end up with 2x squared plus 3x plus 8x. Let me actually bring this down a little bit because we're about to run into the other problem. Okay. 2x squared plus 3x plus 8x. Oh, my red line didn't come. That's okay. 2x squared plus 3x plus 8x plus 12. And let me actually move this over to, oops. So I can just go down. And again, grouping our first two terms, then what terms I'm putting in parentheses, and our last two terms, that's what grouping means, putting it in parentheses, really. And I notice my first two terms both have an x in them, so I'm going to pull out an x, so we're left with x, 2x plus 3. And now this one right here, hopefully you can recognize what the greatest common factor is. This one's a little bit trickier, but we have an 8 and a 12. The greatest common factor of 8 and 12 is actually 4. So we have plus 4, and we have 2x plus 3. And you can sort of tell if you're doing things right, because if we were to look at our two terms here, we have our x, 2x plus 3, and our 4 times 2x plus 3. It's helpful to notice that these two terms, or these two factors, sorry, these two factors are the same. That's a good sign. That probably means we're doing good stuff. And so we pull out the 2x plus 3 because they have the greatest common factor of 2x plus 3. And what did we leave behind? Well, we left behind an x. That's not a good x. We left behind our x, and we left behind a +4, a +4. And now we factor this third one. Once you've factored a lot, hopefully you can get to a point where you can do it in your head and you can do it very snappy, but you can always go back to factoring by grouping, or if you know some other method, you can do that as well. Hopefully this will be helpful with your factoring skills.